Hello and welcome to PH Physics. Today's explainer is the motor effect. A current carrying wire in a magnetic field experiences a force. By the end of this video, you'll know F equals BIL and Fleming's left-hand rule. The motor effect. When a wire carrying current is placed in a magnetic field, it experiences a force perpendicular to both the field and the current. The size of the force, F, equals B times I times L, where B is the magnetic flux density in Tesla, I is current in amps, and L is the length of wire in the field. Three things. 1. Force direction is from Fleming's left-hand rule, first finger field, second finger current, and thumb motion force. 2. Reverse the current or the field, and the force reverses. 3. The motor effect drives all DC and AC motors. Common slip. Using the left-hand rule for induction. The left-hand rule is for the motor effect, the force on a current. The right-hand rule is for the generator effect, the induced current. Quick example. A 5 centimeter wire carrying 2 amps in a 0.5 Tesla field. Force equals 0.5 times 2 times 0.05 equals 0.05 newtons. Wind that wire into a coil and you've got the basics of a motor. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE higher revision planner ready to download, plus the mastery workbooks across maths, physics, biology and chemistry. One for every higher topic, every answer fully worked, every common slip flagged. Simple explanations, serious results. See you next video.